Hello class, I'm away at another planning training day. The last one of this semester. Wait, nope, take that back one more. In any case, today we are learning about Ohm's law, power, and cost. Now, on Monday we actually learned about Ohm's law. I gave you that equation. It's that the voltage is equal to the current times the resistance. Ooh, fancy. So we're going to talk about that in more depth. Then we're also going to talk about power, which should sound a little familiar because it's exactly the same as the power we were dealing with. We were talking about roller coasters. And then cost. In other words, what comes home in that PG&E bill that everyone loves getting. I'm lying. No one likes getting it. It's awful. Okay. Because we hate it. Let's talk about Ohm's law. Ohm's law states that if you know the voltage of something, say the battery, and you know the current in that something, so that'd be the total current coming out of the battery, and you know the resistance of the something, so this would be the total resistance, that those three numbers are related together. They're all proportional. So that means if we know the voltage of the battery, we can find the current and the resistance of the circuit. So Ohm's law is cool because it works for the entire circuit. So let's draw a circuit. Here's my circuit. Here's resistor A, resistor B, and resistor C. The current comes out, it goes down through A, it then splits, some of it goes through B, some of it goes through C, it comes back together and goes back to the other side of the battery. Yay. What I'm saying is that if we knew the total resistance and the total current, we could find the voltage of the battery, or any combination of that. So that's nifty. What's really cool about Ohm's law is it doesn't just work for the circuit. It also works for one resistor. So say we just care about that light bulb. Turns out that the voltage used by light bulb A is equal to the current through light bulb A times the resistance of light bulb A. It's the exact same relationship. Now, that makes our lives way easier. It means we don't have to memorize a bunch of equations. But it gets better. So say we don't care about bulb A. Say instead I care about bulbs B and C together. Well, Ohm's law can also do that. It can deal with the entire circuit, it can deal with just one resistor, or it can deal with an entire section of my circuit. It doesn't matter. The voltage used by whatever it is going to be equal to the current in whatever it is times the resistance of whatever it is. So that's really cool and helpful. Especially since, if you look at this pretty picture that we already have, the current comes out and goes through A before it splits, and some of it goes through B and some of it goes through C. The total current is the current in A. Look at that. All of it has to go through A. So if I could use this top equation, I could solve for current total, which is current A. So I could do 2, 3, 4-step problems if I really wanted to. And right now, we don't. But the last important thing before we can move on is this right here. Any voltage given to you by the battery must be used up by the circuit. So what that means is the voltage of the battery must be equal to the voltage used. And this is why you need to have light bulbs in your circuit. If you don't, if you just have a battery and a wire, all that voltage still needs to be used. So it gets used in the battery itself. It heats up the battery. The battery, actually starts to melt, and horrible, horrible things happen. People cry. Moving on. Power. So power is how quickly energy is used. We use capital P to represent it. And it's measured in joules per second. Ooh, joules. Remember that? Talking about energy. Joules is our measurement of energy. Joules per second, which is also called watts. All right. So, how the heck, though, are we going to get power? So say we have a light bulb. Some light bulbs say things like 70 watts on them. Where did that come from? Okay, well, let's think. Voltage is measured in volts, which, if you recall, is joules per coulomb of charge. Energy per charge. All right. And current is measured in amps, which is coulombs of charge per second. Well, look at this. If we multiply these together, I got joules per coulomb times coulomb per second. That gives me, and I don't want to write it like that. Gives me watts. Joules per coulomb times coulombs per second gives me joules per second, or watts. There's my nifty equation. Now, there are other ways of getting power, but we're not going to worry about them right now. If you really need to know what those equations are, turns out that I squared times R will also give us watts, as will voltage squared over R. But again, we're not worried too much about these yet. Alright, so what do we got so far? We got that Ohm's law tells us about voltage, current, and resistance. And that we can use it for the entire circuit, one resistor, or a section. And as long as everything is for the same level, it works. All voltage given must be the voltage used. And if we really care, we can find out how much energy is being used each second by taking the voltage used by a light bulb and multiplying it by the current in that light bulb. So really what this should say is power of light bulb A equals the current in light bulb A times the voltage used by light bulb A. Alright, fun stuff. Moving on. But say I don't want to know how quickly energy is used. I want to know how much total energy is used. This almost never happens, but sometimes it's important. Okay, well, we measure total energy in joules. Well, if we have joules per second, we got to multiply it by something to get just joules. What are we going to multiply it by? Seconds. If you take the power and you multiply how long your light bulb is on, you get energy. Yay! All sorts of fancy stuff there. So, this means that, say I have my 70-watt bulb, and I have it on for 1 minute, so 60 seconds. I can multiply those together to get an answer. Alright, so I just need to get my calculator. I know, fancy, right? 70 times 60 equals 4200 joules of energy. Awesome. Problem. PG&E doesn't use joules to keep track of its energy. So when it sends you a bill at the end of the month, they don't measure how many joules. They measure how many kilowatt hours, because that made a whole lot of sense to someone. Now, a kilowatt hour still gives you the total amount of energy. It just does it a different way. So what we've been doing is we've been taking watts and we multiplied it by seconds, and that gave us joules. Alright, but that's not what PG&E does. But we're still going to use this equation of power times time to get energy. Except instead of watts, we're going to use kilowatts. Instead of seconds, we're going to use hours. And it's still going to give me energy, but measured in kilowatt hours. Ooh. So, for those of you who don't remember, shame on you, but 70 watts would equal how many kilowatts? Okay, well, there are two ways of doing this. One is the decimal method. You can take the decimal point, which is just right here, and move it over 1, 2, 3. Or you can do your dimensional analysis if you prefer, and say, okay, well, 70 watts. And I know that 1,000 watts is 1 kilowatt. And watts cancel, and that gives me my answer. In either case, you get 0.07, 1, 2, 3 kilowatts. Alright, now we had it on for 1 minute. Whew. Okay, well, 1 minute is 1/60th of an hour. I don't know what that is, I'm going to check. Alright, so 0.017 hours. 0.07 equals 0.001167 kilowatt hours. Yay! Now let's do it with something that's a little more likely. Almost done. For those of you getting anxious, just chill out. It'll be fine. Let's say we have a 1,500 watt engine. Say it's an electric motor. Alright, and we run it for 4 hours a day. I want to know the power. Sorry, I want to know how much energy is used. Okay, well, first I need to know kilowatts. 1, 2, 3. That's 1.5 kilowatts times 4 hours equals 1.5 times 4 equals 6 kilowatt hour. Alright, and this is the number that PG&E is going to use to charge us money. How much money? Well, you need to know what their current rate is. So the rate, that's how much you got to pay. Now, PG&E has this weird tiered system where the more electricity you use, the more it charges you. We're going to ignore all that. We don't care. We're going to pretend that we're not using a whole lot of money, or a whole lot of electricity. So we're in the lowest tier, which means they're charging us 12 cents for every kilowatt hour that we use. Alright, now this rate could be anything. This is just what we're going to use for today. We got 6 kilowatt hours. To find the cost, how much money I'm going to have to pay, I'm going to take the number of kilowatt hours, and I'm going to multiply it by the rate. And that'll give me total money. So in this case, I got 6 kilowatt hours times 12 cents per kilowatt hour. 12 cents being $0.12 because there are 100 cents in a dollar, in case you didn't catch that. 6 times 0.12 equals I owe PG&E 72 cents for running my electric engine, motor, whatever it is, for 4 hours. So that raises an interesting question. How many times do you have to run the dishwasher at your house? And how long does that take? If you knew the power of your dishwasher, you can check, it's written on it, and you knew how many hours a week you spent running the dishwasher, you could find how much money it costs you to get clean dishes. All right, there we go. You have further instructions on Echo. Get to it.